let me introduce you to the IoT platform for logistics. The project in mind was created to help facilitate communication between users and logistics services with the help of Internet of Things. Let's take a look at the system architecture, and I decided to take on the layered approach as I understood that the onion-like model for our architecture will be best suited for all the needs that we have for this project. The outer layer, or the first layer that we have, is our web UI and the Telegram bot. Basically, they allow the users to interact with the program and send requests or different data through the service control layer to the service control layer, to the catalog and the business logic that we have. Then we have the communication layer, which is represented by the two different APIs that we have. We're using two different communication paradigms, the REST and MQTT. And at last, we have the data layer, the MongoDB, the database for storing the persistent data, and the InfluxDB for storing the time-based data, which is always updated. This type of architecture, the layered approach, allows us to have a clear responsibility separation and also the highly scalable and easily containerized microservice-based system. The service control layer is best represented by the two key microservices that we have there. The catalog service, which acts as a middleman and basically routes all the comprehensive data between the systems, as users, as the UI, basically the web app and the Telegram bot can only access the catalog, and then the catalog will send the request to the subsequent repository, which will be then handling the data in the databases. So basically the catalog acts as a middleman, routing, creating all the necessary security, and also creating easily readable and understandable system, which will allow us to properly handle all the requests and responses. As the database sending back the response for any request that was sent back there, will send it through the repository model to the catalog, and then the catalog will be talking to the UI. The business logic side of things is represented by the reputation system. The reputation system shows us that we can work with the different data and which is stored in our systems, and we can create a system for analytics and evaluations. It is crude, but it basically does really elementary functions to evaluate driver performance. And also it can be highly containerized and deployed as a separate microservice, which allows us to scale it and create a good environment for the system. The communication layer, as I said, we're using two different protocols, the publish subscribe and the request response. And the MQTT brokers, Mosquito, we will be using for the time-based data. But for my part, the REST API, the request response sequences, that are the main backbone for the catalog. So basically, user sends a request through the web app, and the catalog handles it and sends the respective request and response to the repository. That repository accesses the database and then sends back the response to the catalog. So the catalog is, again, it is a really good middleman, which allows us to create this like security layer basically. The API highlights that we have for the system is that we can send, like as the REST paradigm demands us to do, we can send the get, post, and put, delete requests, which they're basically exposing the endpoints for the catalog and allowing us to work with the repositories without exposing the database itself. We built this backend with modularity, speed, and scalability in mind. The REST API allowed us to have a clear repository service separation and also a proper data abstraction with creating of this middleman, which also serves as an additional layer of security, where the only thing working with the database are repositories which can only be accessed through the catalog. So, as we are taking on the microservice-based approach, for the additional things that we can add to this project, we can enhance the driver reputation system, basically by using more complicated algorithms inside, and also add the safety analytics, where we can analyze with the AI the different patterns of the drivers and basically additionally assign the safety ratings to them without damaging the current structure and only scaling the project further more.
Okay, now let's start with the web application. This is the welcome page of the logistics system. As you can see, the design is simple and clean, and it has been implemented using Bootstrap to make sure the user interface is both attractive and easy to use. Here, the user can choose their role in the system, as driver or warehouse, and based on their selection, they will be redirected appropriate sign-in or login page where they can authenticate and continue using the system. Now I will show you what happens. And if you choose it incorrect, you can come back to the home page and again choose between these roles. I choose the driver, and you can see two options here as sign in and login. When you can see, it's nice to say that when you hover over these options, they become darker to indicate they are active, and when you move your mouse away, they become lighter again, like this. And also this button here. And after selecting the sign in option, the driver is redirected to this page. It is a form for driver details. The driver is required to enter their details to create new profile in the system. And this information is essential for identifying and managing driver within the logistic platform. The form includes the following fields: full name. Let me now fill it up. For example, Jake, and this is the email. I want to show you that this is like a valid email address, and you should insert it with @. But now I leave it like this to show you what happens if I didn't use @. And this is phone 35, and the address, for example, Torino, license number, and this one like yes. And when I press the submit button, you can see that it shows that there is not a valid email address. And whenever I edit this with an @ and press the button of submitting, I want to show the web app sends a post request here. There are details of the driver, and there is a requested post to the catalog to the endpoint of driver. And you can see also here in MongoDB, in driver, and we have a new driver which name is Jack with these details that we inserted in previous section. After registration, the driver will be able to log in to using their email. Next, I will show you what happens here. We should sign in. We should log in here with the email. Let me check what was the email here. Whenever I press login, it's actually in the here for login and authentication. It requests the get to the catalog to retrieve this information from the driver that we already had it in the MongoDB. Here is the driver dashboard. And this is, as you can see, this is the driver that we created together in the previous step. At the top, there is a navigation bar with different sections of the dashboard: feedback, available packages, selected packages, Telegram bot, and home. When the driver clicks on any of this button, the page will automatically scroll down or navigate to the section directly. For example, available packages. It goes to this section. It makes it easy and fast to access each part of the dashboard without refreshing or changing the page. Here is the section for driver's details that were entered during the sign-up process and are now visible here. This includes the email address, phone number, and the address, license number, and unique ID which be generated by the MongoDB. And there is a reputation score which shows the driver's performance rating, and it is updated based on deliveries and feedbacks that we assume to minimum of it is 1. Everything is saved and loaded from the MongoDB database through the catalog service. The driver also has two important options here: edit profile, delete profile. In editing profile, if the driver wants to update any of their information, such as changing the phone number or address, they can press the button and make the changes. Let me show you. When I press this, there is you can see the form looks very similar to the sign up page that we saw earlier. The driver can now change any of the profile details. Let me change for example, phone number here instead of 676909. And whenever I press the save changes, you can see that the phone number here changed to 909, And let me show you what happens in my code. Let me show you here. Press submit changes. Actually, I request the put to the catalog, and I want to update this details related to this driver. Whenever I refresh it, you can see that the phone number changed to the one that we edited. Okay, now I want to show you the another option, which is delete profile. When I press the delete profile, the web application sends a delete request to the catalog service, and the catalog service then removes the driver's record from the Mongo database. After the deletion is successful, the system shows the confirmation message, which is driver profile deleted, all data recorded with this ID also deleted, and we have a return to the driver option. This means the driver's account and all related data have been completely removed, and the driver can now return to the driver option page. Here I wanna to continue the demonstration using an active driver account that I created earlier. This driver has already signed up and their profile is saved in the system. Let me before check this button also. If I choose driver login and I wanna switch between sign up, login, there is also this option here, and I want to continue with this driver. Whenever I press login, it also send the get request to the catalog and retrieve this information from my MongoDB database. And here you can see also this one. Now that we have feedback, I can press feedback and redirect into this section. And this is the details of our their driver. As you can see, there is not good detail here. I want to change it to the valid one. Here you can see available packages, and we have available packages with the button that I can select between each of them. And also I have this driver has selected packages, the packages that he select, and some of them are not yet picked up from the warehouse that you can see the bottom here, and some of them which are delivered that you can see the status change to the delivered. Let me show you what happens when I press, for example, package 8 and I press select. Now it goes to this section, package 8, and the status is in warehouse. And whenever I press the pickup, the status changed to the in transit. And there is another button appears here which is marked as delivered. And whenever the driver delivered this package, he can press this button, and then this package, which were package 8, the status changed to the delivered. And also we have another section that I told before, feedbacks. These are the feedbacks which are registered by a warehouse, which has this, for example, package ID. The score is 1 here, and the comment is bad, and these are the feedbacks related to this driver. Now I want to continue with warehouse, so I press home, and I change with this role with warehouse. We have also sign in and a login option here. I don't waste time for here because it's the same as for driver, so I switch to login, and I want to insert email that I already registered and press login, so it sends a get request to the catalog and retrieve this special warehouse, and this is the warehouse dashboard. You can see the warehouse details here, and name, address, phone, email, and the ID that generated by the MongoDB. And also I have an edit profile and delete, so it's the same as for driver. We can check the quick response here. This one changed here, and I don't press delete because I want to continue with this warehouse. And there are also some button here, and whenever I press it, I quickly redirect to this section. And also feedback, package history, and so on. For package registration, I should insert the package name. For example, package 21, source is Torino, destination Torino. It has an automatic correction here. You can use site. And of course, in the weight, I choose it, for example, this one. And for dimension, also we suggest the sample that you should insert here, for example. And the delivery address. And whenever I press the register package, it actually, let me first show you, this is the package that comes to the package history section. And also I want to show you the web part here. There is a post request to the catalog with endpoints like this one. And also whenever I refresh it, I can see it in a package in MongoDB. This is the package 21, as you can see. And you can see the driver ID is null. So in the following, maybe one driver wants to pick it up and continue. Also, we have a package history here. There are already some package registered. And you can see the package name, delivery address, driver ID, if it is assigned to any driver, or if not, we can see the none here. And the status of the packages are so important in our systems. For example, this is in warehouse, and whenever this is in warehouse and the driver ID is assigned, you can see the tracking vehicle is green. And also whenever the driver is not assigned, there is not available tracking package here. And if the package is delivered, also there is no availability for tracking. And for tracking the vehicle, whenever I press the track button, tracking part of our system, and there are some post-processing details here, which is total distance and average speed. And there are some latitude and longitude, which generated randomly by our simulation service and stored in our InfluxDB database, which is time series database. And you can see this is the InfluxDB, and I send a GET request to InfluxDB to retrieve all this information related to latitude and longitude. And let me tell you about the feedback. This is the section which if the warehouse submit any feedback for that driver, it will be appeared here, and if not, this shows no feedback here. For example, let me submit a feedback here for this package 7. I come to this section, feedback submission, and when I press this button, it shows me all available packages here, and I can select between them. For example, I select this one, and when I press the package ID, it will automatically fill up all the available details related to that ID. For example, driver ID and package weight. And there is a score which is 1 to 5. You can select between these numbers, and you can select from here, or if manually you insert, for example, a number more than 5, and for example, comment very satisfied, and submit feedback, it shows us that value must be less than or equal to 5, and for example, I insert 4 and submit feedback. Actually, now it's appear here, this package 7, very satisfied, and you can show it. I can show you in feedback section in MongoDB, which is very satisfied related to this package ID. And also it send a request to catalog for post feedback to this endpoint. And the other section here is Telegram bot, which whenever I press this one, we can go to another service which we have it, and it's Telegram.
Explain you about the Telegram bot, which was designed to help both drivers and warehouse employees. To create this bot, we use the bot fodder, which is used to create and manage the bot on Telegram, and Telepod library, which is a library that handles communication and interactions. You can see our bot. It has two different parts, as I told you, for driver and warehouse. We start with the driver. Here, driver or warehouse can enter with their email or their ID. Okay. After entering, there are three main options for a driver. The first one is the viewing the details. Here, driver can see details including driver ID, full name, email address, and phone number. And these are fetching by sending a get request to drivers/driver endpoint of catalog. Second option is pick up a package. This is the most important and frequently used features for drivers. When drivers select this option, they are presented with a list of available packages that are currently open for pickup. Each package comes with a detailed information about the weight, dimension, source warehouse, and destination address of package that help the driver to choose which select they want to pick up. For example, and I should say that the bot fetch package detail by sending a get request to the packages/packages endpoint of the catalog, and its filter and return packages that are not yet assigned to any driver. When driver select a package, for example this one, a message will be appeared that announced it and say that pick up to the warehouse to pick it up. And if we check our database, the MongoDB, we can see at this stage the driver ID of this driver that select this package is assigned to the driver ID field of the package, and here it's updated. This is done by put request. And after drivers go to warehouse and collect the packages, they press confirm pickup. This action update the package status from the in warehouse to the in transit. And for example, you can do it. A message will be appeared that package status updated to in transit, and if we check our database, we can see that status updated to the in transit. As I said, they are done with the put request and updating a status of the package from for example in warehouse to the in transit, or later with the in transit to the delivered. And after the drivers confirm the pickup and then going to the destination and finalizing the delivery, they can confirm delivery, and this way the package status of package will be changed to the deliver. We can see again, and after that immediately the bot send back the driver menu, allowing the driver to continue with further tasks. What happens if driver decide to reassign the order? For example, if we select this and want to reassign it, the bot first asks for a confirmation. A message appears asking you that are you sure. If you press no, nothing happens, and if you press yes, reassign the order, you can see a message comes up and say that the order cancelled and now is available for other driver. So it will be again in the list of packages that can be selected by drivers. This is done by updating driver ID from the specified driver ID to the known through the put request to this endpoint of catalog. And if we can, if we see here the MongoDB, we can say that driver ID is in the predefined mode. And this is the only point that drivers can cancel a package, because if they select a package and confirm pickup and a status change to the in transit, they cannot cancel and reassign order, because they already have this package with themselves. They received it. So if they try to reassign the order, a message will be appeared that the package is already in transit and cannot be reassigned. Drivers menu is the panel. Since drivers can select multiple packages, these sections allows them to manage their assigned package. In the panel, the system display only the packages assigned to the current driver along with the relevant actions based on their status. For example, if the driver has not yet confirmed the package pickup, two options are available: confirm pickup or reassigning order. We can see that its status is in warehouse, so a driver can reassign it. But if the package has already been picked up and confirmed by driver, so the only option is confirm delivery. You can see that these packages are in transit, so driver can only confirm the delivery. All of these packages management and actions are handled using backend API calls, a get request to fetch the list of assigned package, and put request sent to update package attributes such as status from in transit to delivered or driver ID for their reassignment. As the last question, what happens if two drivers select the same package at the same time, or one selected after it has already been picked by another driver? In such a case, the system ensures fairness by assigning the package to the driver who selected first. Let's try it. For example, here, if we select it, we can see that this package has already been assigned to another driver. Please select another package from the list. So this mechanism avoids conflict and ensure that each package can only be assigned to one driver at a time. This is achieved by immediately updating driver ID in the details of the package in the database as soon as a driver sends its request through the catalog. Part of system designed to facilitate warehouse related tasks. Warehouse user and employees can enter with the warehouse email or warehouse ID, and when they enter, they can see three main options designed for the warehouse. For example, the first one is the view warehouse details. Here they can see the name, address, ID, phone, and email of warehouse. This is done by sending a get request with a warehouse ID to the warehouse/warehouse endpoint of the catalog. The second part of the warehouse menu is track package. It is integrated to help warehouse users monitor packages that are related to their warehouse and are currently in transit. So by pressing this button, it shows only the in transit package related to this warehouse. We can see a list of them, and by pressing each of them, for example, this one, we can see detail of package including name, weight, address, as well as driver ID and name who is carrying it. Additionally, it includes a status message that confirms that package is in transit. And below of this message, there is another button for tracking on the map. By pressing it, two options will be appear: Google Map links and static map. Using these, the user can track the package. For example, here, this allows user to track the last known location of driver using the Google Map link that it opens Google Map application and show the last location of driver who carry that package. Another option is a static map image. This option displays driver location right inside the bot using an image generated by the Google Static Map service. This offers a quick view without leaving a bot interface. But how this tracking happens? As we know, the location coordinates, latitude and longitude of drivers are stored in InfluxDB, which are continuously transferred via MQTT service to here. To fetch these locations, let me show on the code. Okay. To fetch this location, the bot sends a GET request to Influx API endpoint location with the vehicle ID and period as a parameter. So once the latest coordinates are retrieved, the bot generates a Google Map links by formatting here, by formatting a URL like this, which user can open directly the Google Maps app or browser. And it's similar for the static map image. Here, okay, we can see that a static map image, by sending a GET request to this, will be built, and the received image is then sent directly inside the bot Telegram chat for the user. And also here we added another option at the bottom of the these in transit packages. Another button is there, track delivered or delivered search. Here the user can enter a package ID of any packages to track it. For example, here we can enter this one. We can see that this is a delivered package. We can see the package details with the information about the ID and name of driver who delivered this package and the status, which is delivered. Or even we can track package that's actually are in warehouse. For example, this one. we can see we have the package details with a message that show that this package is in warehouse and waiting for a driver to be picked up. Available for the warehouse user is register package option. This option allows warehouse staff to register a new package so drivers can see it and pick it up later. To do this, the user have to answer 4 different questions. For example, here we can do it. And at each step and after answering each question, they have to confirm and continue. For example, and after answering all questions, the bot generates a review message summarizing the entered information, and at this point, user can either submit the packages everything looks correct and or edit individual details. For example, here I can edit the name to IoT, for example, and then submit on the package. We can see that the package registered successfully, and we can see the data. It generate a package ID for it, assigned to it, and give it back to us. And here we can see it in the list of packages. We can see it here, IoT packages. It doesn't have driver ID or it's a status in the warehouse, and this is done by sending a post request to packages and point of the catalog. All main commands with short description are suggested to user when they type / in Telegram bot interface. These commands include /panel, pick packages, driver details for driver part, and /warehouse details, tracking packages, and register package for warehouse user. They include the 6 main functions that I introduced you. And by entering any of these commands, for example, warehouse details, the users are immediately directed to the relevant part. And you can see it happens if they are already logged in with the appropriate role. For example, a warehouse user, as we log in as a warehouse user, we cannot redirect to the driver related parts. For example, if we do this, we can see that a message will be appeared that say you need to log in first. And moreover, the /stars are always available for switching between parts if you need it. And also for easier navigation, a shortcut system has been implemented. This makes even easier for users to go favorite part. For example, here we can type T that show the tracking package, or TR doing same, or for example W, which is in the warehouse details, or for example D for the driver details. We can see complete list of them here. Some of them for the designed for the driver shortcuts, and some of them is for the warehouse users.
So now, just to wrap the things up, here we have our latest version diagram. Here in our diagram, we have 2 kind of databases. One is NoSQL database, and another is time series database. Actually, we store all types of general data of our objects into NoSQL, which is MongoDB database, and all the time series data, which is in our case, they are latitude and longitude of the vehicle position, into InfluxDB. The latitude and longitude of the vehicle actually goes through MQTT protocol to InfluxDB and get stored there. And all the services can, as it already explained, can access the MongoDB through the catalog. So now I will show you the structure of our MongoDB NoSQL database. As it can be seen here in the model, model driver, here we have the class named driver, which is, in essence, we build the object. We actually define the driver object here with the class driver, because we thought maybe having the fixed number of attributes, fixed data type would help the actually working database more smoothly. So for example, for driver, we have these attributes: vehicle ID, car model, and etc. Here we managed to actually the type conversion to dict, which actually convert the object into dictionary to be stored in database and to pass it to the end user, and from dict, which makes the object out of the dictionary type, because as we saw, it's more convenient to manipulate the data as it's treated as an object. So we have the same for like feedback, for packages, and for warehouse, and then we have repositories. Repositories, actually, here we instantiate the collection for each driver, for each feedback, for package, and for warehouse. We have these collections, as we already can see here in the config.json. It's a configuration to instantiate the database for each collection we use, and we store the driver data into driver collection. So here we can see instantiation of the collection and the MongoDB, all the queries that we actually use to store the data, to manipulate the data, to retrieve the data, not the manipulation, but that fetching the data that we want to pass to the user with the functions, with the queries that we already implemented in the repositories. And same as the model here in the repository, more or less they are just for the scalability and being more readable. We divided each collection's queries, and here it can be seen in the util file. Okay, here is just the function just to read the config file. So now we move on to our time series database. Here, same as the MongoDB, we have a configuration file, just a configuration JSON file, which the class influx manager can read the config file and get instantiated. So here in DB connector 3 file, we have influx DB manager, which actually it's all the queries that we use to write the data into InfluxDB, to retrieve the data, and do some post-process queries. Like we show all vehicle and map, which you already have seen in the Telegram bot and the web app. So here we implemented all the queries that we needed, and the user can have access to InfluxDB through these API endpoints, which is provided in Influx service file. So it's like a catalog, but specifically for InfluxDB. Here we provided the endpoint to get the access to all the queries that we have implemented in the DB connector file. So here, as you can see, we have different URI to get different kinds of data that the user might need it. Here, we have your vehicles URI. Here we have all vehicles URI, which provides the different type of data for different periods. Here all can be seen. So at the end, here is the Influx connector server, which is our endpoint to all the queries that are implemented. So and at the end, I will show you the catalog. Here you can see the catalog. We have different classes for driver, for warehouse, for packages, and for feedback. So basically each class is different server. So we have 4 endpoints with a different URI, which provide the access for the user to retrieve all kinds of data that it might require. So here at the end, they're all shown, and that's all. Thanks for your time and for your attention.